Good evening, students. Once again, I am Professor Dr. Sardar Ali to talk about the NEET Physics class, chapter number 4, Alternating Current. In this, we are discussing about the lesson in continuation to the previous lesson. The name is Fundamentals of Alternating Current Circuits. First of all, you must know what is the meaning of circuit. So it is defined in this way technically: a path through which an electric current flows or intended to flow is called as electric circuits. They will be named with type of the current flowing through them. If direct current flows through the circuit, that will be called as the DC circuits. If the alternating current flows through the circuit, that is called as AC circuits. It will be having its fundamental rules. For understanding the fundamental rules, we must discuss through the basic things. That is, we should understand the vector and its other parameters. Now you may be thinking, why should we discuss about the vector once again? Why? Because it is understood that all the electrical quantities are vector quantities. That's why we must define first of all the vector. This is a vector. So, for your understanding, a quantity, a physical quantity, that too, which possesses both the magnitude as well as the direction, will be called as vector, which is represented by a straight line and an arrow mark at the end. Length of line gives the magnitude and an arrow mark shows the direction. Similarly, the second one and third one, like that we can discuss in-phase vectors and out-of-phase vectors. And what about the phase or phase difference? Then lagging vector, how you are going to define and understand, and leading vector, and how to draw the vector diagram. Everything we have to discuss here. Coming to in-phase vectors, the radial vectors which are working parallel to each other or which are represented parallel to each other, which are having the equal or unequal magnitude, will be called as in-phase vector, provided they should have zero phase angle difference between them, like voltage and current. They must be possible to represent on the same line representing the 0 degree. They are said to be in-phase vectors. So in electrical engineering, as far as the alternating current is concerned, which parameter or which element will be having the in-phase property? That is pure resistance. In case of pure resistance, voltage and current will be in phase with each other. In preceding chapters, once again, we can discuss about this. Then what do we mean by the out-of-phase vectors? If two vectors, they are acting with an angle, say alpha, beta, theta, etc., in different direction with equal or unequal magnitudes, will be called as out-of-phase vectors, as it is shown here in the vector diagram. Then what about the phase or phase difference? The relative position between the two vectors, either in terms of the degree or radians, will be called as phase or phase difference or phase angle, etc., which will be always represented in tangent of the angle. In the next class, I will explain about this in detail. Then what do you mean by lagging vector? A radius vector which rotates in clockwise direction from the reference line will be called as lagging vector. Here you can see I is lagging V by 90 degree. On the other hand, leading vector, a radius vector if it is rotating in an anticlockwise direction from the reference line, that will be called as leading vector. What are the example of the lagging vector and leading vector? In case of pure inductance, current will be lagging the voltage by 90 degree. In case of pure capacitance, current will be leading the voltage by 90 degree. Then what about the vector diagram? A figure which is representing the number of vector quantities acting at a point in different direction with different magnitude representing some angle with them, that particular figure will be called as the vector diagram. For example, like this, number of quantities you represent here B, phi, P, I, etc. Such figure will be called as the vector diagram, or otherwise the same will be called as the phasor diagram. Along with this, phasor difference also can be represented like this. This is also will be as the phasor diagram with voltage as well as the current. This is voltage, this is current. You can see that the current is lagging the voltage by 90 degree in this particular. It means it may be passing through the inductive coil. That's why it is like that. So much more we will be discussing in the next class. Thank you.